fai partire.
Sure. Okay. There's one thing which is far more unpredictable than the universe, which is human behavior, of course. I've been asked by the organizers to stimulate the discussion because perhaps nobody would have nothing to say in the discussion, but I think I'm completely useless. There's been an enormous amount of discussion. It's late. I would like to do two things. First, I think that the last talk has not had any questions, so let's just get some question time for the last talk, which is very important for you to get some raising hands. And then I have circulated you have seen all of this, a request of options to discuss, expecting that nobody would write anything, or there would be a couple, and in fact there are pages of topics to discuss. So just reading that will take a few times. So I suggest then, I'll take a look now rapidly from memory, that I just photocopy this and circulate to send it to you by email, because probably just a list of issues raised would be a good way of exchanging things. Also,
could we also debate, no? Yes, on in German.
Let me read first. And we might want to keep this short. Maybe we don't, I don't know if you want to continue for long, but we also time is the end of the day. So let's first ask questions in the last talk. Some people want to say. Yes.
No one else has a question. I'm curious about the dent. And if you plot the distribution of, you must have 400 or 500 multipoles. So if you plot the distribution of multipoles as opposed to the power spectrum, does it look very similar to that?
I'm not sure I get it. The distribution of multiple on the sky, the distribution
Yeah,
on the sky.
just take them all the multipoles, because you must have 400 or 500 in there.
Well, yeah, I mean, well, square. Yeah, more closer. I don't remember. I think we played that game, but I don't remember that there is anything special for the amplitude. I mean, you know, like they would be like some particular alignment and so on. The kind of bizarre things we found were not, again, correlated directly one-to-one between the L20, for instance. The alignment is more like, you know, optical lower modes. The statistical asymmetry goes to actually all the modes going from there. So I don't think there is anything that relates visually, if you wish, a direct signature.
And just a quick comment. The running,
yes,
you could get lucky on running. And so just because there were, papers saying that it should be 10 to the minus 3 doesn't mean.
Oh, I'd like to stress that. I mean, that precisely. I mean, there is a question of, on one hand, guaranteed returns, okay, which is, well, I mean, you know that if you reach a certain level, you're bound, say, for non-gaussianity, if you reach Battle bound, well, it's order of the NS-1 for FNL local, well, if you don't find anything, I mean, you've changed physics. But then it's not because there is not, a prediction that is true. If the current physics tells you that there is a priori nothing, I mean, I think that as a physicist, I think we should still look and check whether this is actually true. And so
that's what I'm saying, is that it's worth looking for, and it's a squishier.
Indeed, but that's a little bit more difficult. As you've seen, I've been involved in writing these proposals for funding, and asking for a $750 million for something that would be, well, maybe we'll find something, even though there is no predictions, is a little bit will be put as a weak point.
You mentioned that insularization in particular could be measured to much more accuracy, to much higher L, millions of more. Could you elaborate a bit more on what that might imply?
Well, I mean, many measurements, not all, of course, that one may think of doing are actually, the uncertainty goes like the square root number of most. It's an approximation, but, and so in temperature, well, you're bounded, as Joe mentioned, to be, L max, so 3,000 people, so square for the full number. That's about what you can do. Well, I think in polarization, in chemo, you can go somewhat further, and so you might be hoping to be able to somewhat lower levels in terms of uncertainties. If this is something that has a signature in polarization, of course. So you need to have physics.
Yeah, there are limits to what is accessible with polarization.
Yes, and as you mentioned yesterday, if you are trying to go all the way to Medicina bound for FNL, that is typically of the order, trying to CMAC FNL is 5. Okay, so if you're trying to go to, NS minus 1, say, so you need 0.05 typically, so you need a factor of 100, so you need 10,000 more modes. That's, the CFD will not deliver that, no way. The only meager hope is to go for intensity matters.
Oh yeah, I have a short question.
Yeah.
Francois.
Yes, I'm
So,
listening.
in the CMBS4, there was a discussion and there was like rumor that the European agency didn't support because of core being too expensive. But there are other plans, maybe this can be, you can go around it. But is there any chance that you will collaborate with like BERT, for example? We're supposed to be in Japan and people will ask us. Now that ESA is not so happy to pay.
Well, first of all, I mean, the issue is not me personally. The question is the European community. The client community was sort of typically 250 strong. And so if we didn't get the sort of money pot of M5, which was like 550 million plus countries. So that now is sort of at the level of individual agencies. So we're talking of, maybe tens of millions. Well, I don't know what the Japanese, want to do. Do they want to get 300 Europeans that will contribute only 1/10 of their cost of their experiment? I sort of doubt it, but so it's not a question of whether we'd be interested in collaborating. Is there any option?
Yeah, because
That I
they
don't
probably
know.
will ask the same question. And I was wondering if there's any understanding. So in principle,
Well, this business about non-selection is very recent. So we haven't got to the point where there has been any serious discussion since then about saying, well, what is really doable? And I can only give a more of a impression. That is, I'm not particularly optimistic given the size of the community, the amount of money that is available in Europe. So I personally think that for Europe, this is we're probably more likely to try to build up a participation to S4 on the ground. I think that's what we need to do if we want to contributing to this area of science. I think it's very likely that the ground will rule the field for probably 10 or 15 years.
and this is reasonable because they are saying that the ground-based may actually go much below if they will find a good situation. They don't know yet.
May I object to this? Yeah, I'll just, a very quick objection. Don't underestimate the power of dust. There is, on the ground, you have no control.
Okay, you have to fly.
The atmosphere is not nice to us. It's not transparent at frequencies above, say, 250 gigahertz, where it would be the dust tracer.
Judge.
In your very beautiful talk, you showed this progress, but there's data as keen data. Now, I presume, obviously, you've subtracted out the dark time.
Yes.
Actually, made it at the dark moment we've taken it out. Okay, now in the old days there was a big red band across, which was our own emergency permission, and that big red band isn't there. Is there some process for subtracting it, or how have you got rid of that big red band?
Oh, yes, so this is actually where we spend a good part of our time. Yeah, I mean, I skip on this, but the first product, say, of WMAP or now Clang is actually sky maps per frequency. And there the galaxy is very, very visible.
Yeah.
As well as, it's more tenuous, so you have the low clusters, point sources, you name it. So all the work is actually to glean from all these astrophysical signals to be able to get to the map I showed you on the spectrum.
Yeah.
So there is actually maybe 100 years of person power into this cleaning process, which I, for the interest of time, I sort of just skip.
I accept it's legitimate for you guys to do that, but in some sense, us theory guys should be told roughly what you've done to do
When I give a 1 hour talk, I make sure that I walk everyone through the main steps.
Yeah.
25 minutes does not allow for that.
Sure.
Sorry.
Exactly.
Even though I took more time than that.
I look at everybody in Facebook here,
I
and I
have
see a lot.
one point.
Okay.
So, after George's talk, I have no way to make this comment. I'd like to do it now. With regard to you being happy if inflaton is Higgs, how we will know if inflaton is Higgs field? And so it is an interesting situation that in the future there is a way that it can be falsified. It may not be confirmed because there will be degeneracy. And so what the prediction is that we should find those B modes at the level 3 or 4, 10 to the minus 3. Okay. If they don't find them there, it is likely not Higgs. If they find there are few models with the same prediction, it will be probably inconclusive. But at least it is to some extent a falsifiable question by the data.
So I think that's really important because, as I said, it gives you that connection which you don't have.
I totally agree. I even will say to people who write proposals
And
that this question is precisely most likely answered by satellite missions rather than ground-based.
What's interesting, if you look back at the 1982 paper, the Cambridge Conference, you'll find they had just taken for granted that the infratron was there at that time.
But that's precisely one of the big drivers of, for instance,
Yeah.
proposal was to be able to sort of exclude or confirm at 5 sigma level Higgs inflation. Or Sarabinsky. That is actually one of the big drivers because there you have a direct connection.
Yeah, I'd like to add to this discussion of distillation. So what happens is that you have several models which are in the leading approximation in 1 divided by the number of folding inflation give the same answer for NS and for R. And that is Higgs inflation and Stravinsky model and our alpha drafters for alpha equal 1, etc. So they give in the leading approximation the same. The thing is, however, that the value of n required for these models is slightly different because it depends on post-inflationary behavior of the universe, like, for example, the speed of reheating and the equational state of the universe after inflation. So if you have very precise measurements of NS, these several different models, they will be measurably different. At the level of core, for example, you could distinguish between them.
Yep. I don't know if it is the quality of some lot of people in this group with a small number, the way this has been organized, but I really participated in a meeting which has been so interesting for me and so rich of exchange between ways of thinking which are also very different one from the other, and at the same time capable of talking to one another. So I don't think we need much discussion here, more discussion here. long time, in spite of the fact that obviously Zealand is like discussed. So I would like to, because of the way these 3 days have gone, to thank our friend who brought us together, Vincenzo Toluccio, Alfio Donanni, Stefano Bellucci, Fabio Scardini, and especially Gabriele Gionti. Thank you very much. Tomorrow morning, all of us will hear another point of view.